Good morning, everyone. I'm Dr. G. Kalpana Devi, working in K. Ramakrishnan College of Engineering in the Department of ECE. I am here to explain about research projects which is carried in RF and microwave domain. In RF microwave domain, it is a recent technology that so many researchers are going on. That design of antennas, filters, power dividers, isolator, circulator, amplifier. So everything can be designed by using many simulation softwares available like CST, ADS, then HFSS, IE3D softwares. That in our college we are using HFSS software and ADS software, which is a licensed version. By using this software, and we have formed that RF domain. That in this, nearly 7 to 8 faculty members are collaborated in this, and four doctorate members are available, and research scholars are present in this RF domain. In this, we are designing RF antennas for so many applications like WLAN and sub 6 gigahertz frequency, that 5G applications, millimeter wave application, underwater communication. So, and we are designing so many antennas by using strip line, CPW line, and fin line techniques. So these are the this general things which is carried out, and I am going to explain about that after completing this research and all the project which has been applied for patent, and also that it will be published in many reputed journals. And I am here to explain about the papers what we have done. This is one journal paper, so written by our team. So this is a trapezoidal slot antenna design which is carried out by our team members. So in this, so trapezoidal slot antenna is designed by using DGS structures, that is defected ground structure. And so this is the structure which has been shown, and the metamaterial shape which has been introduced in this ground plane. So in the top layer, that different hexagonal shape and uh, structure has been implemented, and so analysis are made. So while writing the paper, first we need to choose the title. So, and here there's a title which has been chosen as a printed trapezoidal slot antenna with twin ports for autonomous vehicle. And so abstract in abstract, nearly the 10 to 15 lines. In this 15 lines we need to give that the overview of project for what we are doing and what is the structure we are implementing. So everything which has to be represented in abstract, so it is represented. After that, based on the title, we need to give some of the keywords. So under the keyword, it should be a specific keywords, and after that, the introduction, it should be placed in introduction. The first thing we need to give, what are the literature review we made to write the papers. So, and here near that 30 to 35 papers we need to go for this literature review before doing the project. So, and after that we need to come on conclusion. Based on the conclusion, we need to get our objectives to design that. So here also it is made, and after that, so design trapezoidal slot antenna. So slot antenna which has been introduced to change the frequencies, so that is implemented. And after that, the design procedures has been explained. So and analysis. So here by using this HFSS software, we are getting a simulation graphs. So in this S11 and S22, that means return loss values which has been shown here. So and it is more than it's a minus 10 dB. So it shows that for ideal antennas, so return loss it should be more than 10 dB. So then only we can get the 90 percentage of signal transmission, and it is achieved, and it is proved that our design antenna which sacrifice the parameters. And after that, we have obtained the insertion loss, and isolation loss is also achieved, and radiation pattern graph which is mentioned. So for antenna, We need to explain about VSWR, return loss, radiation pattern, current distribution, gain, any parameters we can obtain by using HFSS software, and all the things which has been plotted here. So and everything, all the values, it shows that the design antenna, it achieves a good parameters. And also not only this simulation, and it has been fabricated. So the fabrication structure which has been shown here, and by using FR4 substrate with the thickness of this 1.6 mm, it is fabricated. And so this fabricated structure is also given, and the measured results. So it is also measured by using vector network analyzer, which is present in our department. And here there's a table, it shows that. So there is a good agreement between the simulation and measured graph. And so the small size antenna which has been designed for V2X applications. And after that, so we need to go for the references papers which has been listed. And finally, see, this author biography has been introduced. So like that we can write one paper, first starting with the title, and then abstract, then introduction, then design. And after that, so all the design we need to make us a table, then conclusion, references, and then so declaration. So everything it should be present. So thank you.